Welcome to Chemistry with Dr. G. I'm Dr. Z, and in this video, we are going to discuss the metallic bonding. So before we start with metallic bonding, there are three types of bonding: the ionic, covalent, and metallic. You can find the link to both the covalent bonding and ionic bonding in the comment section for this video. So let's start off by talking now about talk about metallic bonding. So metals consists of a giant structure. The electrons in the outer shell of the metal atoms are delocalized. So we can see the electrons. So metal consists of positive ions and electrons, delocalized electrons. The metallic bonding comes from the strong electrostatic interaction between these delocalized electrons and the positive ions. These forces of attraction hold the metal atoms together in a regular shape. So this is the metallic bonding. The structure that are held together by metallic bonding are both metals and alloys. The delocalized electrons and the metallic bonds are responsible for the properties of metals. So let's go through the different properties of the metal and try to explain how the delocalized electrons are responsible for these properties. First of all, we know that most metals are solid at room temperature because this is because the electrostatic forces between the metal atoms and or the metal ions and the delocalized electrons are very strong. So metals will need very strong energy to break these bonds. Most metals have high melting and boiling points, so they are solid at room temperature. The second property is the electric and heat conductivity. So we know that metals are good conductors of heat and electricity, and the main reason for that is because of the delocalized electrons. Because delocalized electrons can carry electrical current and heat energy through the whole structure. The third property is the malleability. So we know that most metals are malleable, meaning they can be hammered into shape. And the reason for that is because the layers of the atoms in a metal can slide past each other. As we can see here, they can slide past each other and making the metal malleable. So they can be bent or hammered or rolled into flat sheets. So what about alloys? So what is the difference between metals and alloys? Alloys are mixtures of consists of a mixture of elements. One of these elements must be metal. So it could be a pure metal with another metal, or it could be metal with another element. So either two or more metals or a metal with another element. Uh, why alloys are important and useful? Because the problem with pure metals that pure metals are often too soft. So to make these metals harder, they are mixed with other elements to make the alloys. So these are pure metals here, and this is an example of an alloy where you can find a different elements in the within the giant structure of the pure metals. Alloys are harder than pure metals, so they are more useful than pure metals. The main reason for that is because different elements will have different sizes. As you can see, the blue ones, which are the different element, it has a different size than the size of the pure element. And when they are mixed together, the new elements with the different size will distort the layers of the pure metal and make it more difficult for the layers to slide past each other. So this will make the alloy harder than pure metal. So we can see that pure metals are malleables here because of the layers can slide past each other easily, but alloys are more brittle because of the introduction of the different sizes of the particles. They will distort they distort the layers of the pure metals, making it harder.